Hey programmers, welcome back to day 5 of the Advent of Code. So let's jump right into today's problem. Warning, we have spoilers ahead of course. So the story behind today's problem is about taking your seat, or rather finding your seat, in a plane. We have a very particular algorithm when it comes to how we'll go about doing that. When it comes to the input for our problem, we're going to be given a text file full of different strings. Here's just one example of a string we could be given. Notice that there are only 4 types of characters that we'll have in our string. Every string is going to be 10 characters long, and we can actually break that up into 2 pieces. If we look at the first 7 characters of the string, that gives us all of the row information, and the last 3 characters give us the column information. By knowing the row and the column, we should be able to identify where exactly our seat is. And so you're probably wondering, what is up with the letters within the row info and the column info? Let's break it down by looking at just the row information right now. So they tell us in the prompt that we're going to have 128 different rows, and they're going to be numbered from 0 up to 127. And the characters in the string are going to tell us exactly which row that our seat is in if we follow a very particular algorithm. So what is that algorithm, you ask? Well, it's basically a little spin-off of binary search. In other words, for our 2 different characters, if we have an F, that means we should look at the lower half of the range. And if we have a B, that should give us the upper half of the range. So every time we look at a character, we should be able to basically cut in half of the search space in which we're looking for our seat. And so let's break this one down. We're going to use a classic binary search strategy by having 2 pointers to the bounds representing the range that we're searching within. I'm going to have low start at 0. I'm going to have my high pointer start at 128. The first thing you'll notice is when it comes to my pointers, I start my low at 0, which is okay, I guess, but then I start my high at 128, although the last valid row number would be 127. So you are going to have a little off by 1 action here, and it's actually really important that we have that in our implementation. Having your high pointer be exclusive is actually a little trick that will work in our favor in the long run. So overall, don't forget that your low is going to be inclusive, whereas your high is going to be exclusive. So we'll start by iterating through our input, looking at every character. So I start at this F. I know that the F tells me I need to take the lower half of my range. Well, if my low is 0 and my high is 128, then if I want to take a half, then I'm going to have to know what the midpoint is. Taking the midpoint of these 2 is really just going to be 64. And since I want the lower half, what I should do is take my middle point of 64 and overwrite my high pointer. And if I do that, now I'm looking at the range of 0 up to but not including 64. So it is the case that I took the lower half. And this algorithm continues. Now I have B, which means I'm looking at the upper half. The halfway point between 0 and 64 is just 32. And because I want the upper half, that means I overwrite my low pointer with the 32. And we keep following this pattern really all the way through the end. You'll notice that as we continue this algorithm, our range gets smaller and smaller until we can actually pinpoint exactly where our seat is. Now that we're at the end of the algorithm, it looks like we're going to set our mid as 45 and we're taking the lower half, which means that we overwrite our high with 45. And at this point, my range reads 44 to 45. But remember that when it comes to how we set up these boundaries, our high is going to be exclusive, while our low is inclusive. And so if that's the case, then our seat must be exactly in row 44. And that tells us the row for our seat. But don't forget, there are actually some other characters to consume in our input. We have to figure out the column using the other 3 characters. It's a very similar algorithm. They tell us that there are a total of 8 different columns, and they're going to be numbered from 0 through 7. For the columns, an L means we should take the lower half, and an R means we should take the upper half. So now we can just run the same algorithm as before, except we'll initialize our low to 0 and our high to 8. So I start at the very first character, I have an R, and I know the midpoint between my low and high is 4. I want to take the upper half right now because I have an R, and so what I'll do is overwrite my low with the 4. Next iteration, I have an L, and my midpoint is 6. I want to take the lower half, so I overwrite the 6 on the high pointer. And then finally, at the last iteration, my mid is 5. I want the upper half, so that means I should overwrite the low with the 5. And now that I'm done consuming every character of my input, I know that my low is inclusive and my high is exclusive, which means that my column is exactly column 5. At this point, I have both pieces of information that tell me exactly where my seat is. However, the battle isn't over yet. In this problem, there's a little more to it. What we should do is actually get the seat ID. And to do that, it's just a kind of arbitrary formula. We take the row, multiply it by 8, then add it to the column. So we just do a little math here, and that means that this example has a seat ID of 457. But wait, there's more. What we have to do is also really figure out not just, what the seat IDs are, but rather what we want to do is find the maximal seat ID. So it'll just be a little max value logic after that. With that, I think we're ready to code this problem up. All right, so here we have our text file. Has a ton of different lines. Let's go ahead and start interpreting those lines. So in part 1 in my file, I have just our classic boilerplate. I'm going to start by splitting the contents of the file on the new line character. That way I just get an array of every string. So we'll just go ahead and console.log what those lines look like. We'll run this part 1. Cool, so there I have my data. It's pretty huge. Why don't we build most of our code kind of just operating on a single one of these strings. So let's go ahead and do that here. Well, in the grand scheme of things, I need to basically run the same algorithm on the first 7 characters and then separately on the last 3 characters, right, to get the row and column respectively. So let me just write a function, and we'll kind of assume that it operates just for the rows right now. I'll call that, binary find. And I'll go ahead and take in the string. Then along with that, we'll want to go ahead and begin our algorithm, right? What we'll do is design our code with the example that we walked through on the whiteboard in mind. So this is going to be our original input. I'll put in a comment. But for now, I should be calling binary find to test it just with a string of the first 7 characters, as if we're taking the rows right now. So I'll just have this test case. And so let's start by creating those 2 really important variables that we need for the algorithm. So I'm going to need my high and low pointer. So I'll say low can begin at exactly 0. And then for my high, it'll begin at 128. Something really important we mentioned in our sketch was the high is going to be exclusive. So although my high is 128, I should be able to find my row number in the range of 0 through 127. Cool. Then I can start by iterating and looking at every character of my string. So I'll say let char of the string. And so since I'm just designing this function for the row finding, I'll just use f and b respectively, right? So I'll check, hey, if my character is a f, and otherwise if it's a b. Recall that when we have an f, that means we should be taking the lower half, because it's like the front of the plane. And then if it's a b, then we take the upper half. And at any point in time, we do that by, replacing either low or high with the midpoint. So I can just create that variable here. I'll say const mid. And to take the mid between 2 numbers is really just taking their average, right? So it's as simple as taking the sum of low and high, rather. And then I can just divide that by 2. Occasionally, what if we have like an odd amount of numbers? Then what we can possibly do is maybe math.floor this. And it should be good to go. Very similar to just classic binary search code if you're familiar. Nice. So now in this first if statement, right, if the character is f, I want to take the lower half, which means that I can ignore the upper half. If I want to ignore the upper half, then I can just set my high equal to the mid, right? So do a quick sanity check here. Let's say I start my algorithm and high is 128. If I see an f, I want to take the lower half, which means that mid is 64. So now I'm looking at the range of 0 through 64, right? Because I changed high to be the midpoint. On the flip side, if I want to take the upper half, then I raise the low up to the midpoint. Cool. So that'll be my main algorithm. And then after I'm done running this entire for loop, once we kind of converge to a single element or a single number, then I should just return it, and that's going to be always in my low pointer, right? Because remember that our high is going to be exclusive. So basically, once low and high are just right next to each other, we're basically targeting a single number. So this code is looking pretty good. Let's go ahead and just test this binary find. And so if this helper function is working, we should get back a 44. So let's give that a shot. Nice, and here I see my 44 at the tippy top. Cool, so here I have the binary find function. It just works for my row data. And I don't want to just copy and paste it and kind of redo it all for my column data. Why don't we just make this more dynamic? And so we can imagine that maybe a more specific call to binary find would be with, our string data. And then also maybe the symbols that we'll use to check what's high and what's low, right? So here I'll pass in F and B respectively. And then along with that, maybe I'll also give like the maximal number. So basically here I have 128 different rows to choose from. So that's what I'll assign it here. And so to make this dynamic, now I'll just kind of add my arguments here. So I'm going to take in the string like before, and I'll also add arguments to take in the F and B respectively. Maybe I'll call that bottom half. We'll say bottom symbol, as well as my top symbol. And then finally, I'll take the total number. So here I'll just take in some number n. So now to kind of spruce this up, we'll make the high equal to n. And then we'll make f equal to the bottom symbol. And of course, the b will now be the top symbol. So I shouldn't get any different behavior from this small refactor. So we should still get the 44. Let me comment out this line as well. Let's see what we get. Nice, still 44. Now the upshot is we can totally test this also on the column data. So I'll just steal the last 3 characters of this input. I'll pass that in. Then I'll just adjust all of the logic. So for the bottom half, it's going to be an L, and for the top half, it's going to be an R, and there are 8 different columns to choose from. That's part of the problem. And if this is working, the answer should be just a 5 here. So how does that do? Nice, it also works. I think now we're ready to put everything together. So over to our main function. Here I have all of my lines. Let's go ahead and now turn all of these lines into their actual IDs, right? So I'll iterate through them, maybe with a map. Let's say lines.map. And now for every line, let's say every line is fine. For every line, I want to find its row and find its column. And so I'll start by getting the different parts of my string. So I can do line.slice. So I want to get the row information, which would be from 0 up to, but not including character 7, right? So I would get indices 0 through 6, which is the first 7 characters. So I'll call that my, let's say, row string. Then I'll do something similar for the column string, right? And to do that, I'll start slicing at index 7, but go through the end, so this should be fine. Now it's just a matter of calling my functions properly, right? So I can get my row number by calling binary find like before on my row string. And I'll pass in my bottom and top symbols. So F and B and 128. And then very similar for my column. At this point, I just want to plug in these values into the formula to get the ID. So that should just be as simple as returning 8 times the row number. And then I just add the column number, just given in the problem. Nice, and that'll give me all of my, we'll say, seat IDs. So map returns an array of all of these return values, basically all of the seat IDs. So I'll save that. And this main problem has us really find the max seat ID. So I'm gonna use some built-in methods here. I'll say return math.max, and I'll spread out the seat IDs array. And that should just give me the maximal value. So maybe you're not familiar with this combined syntax, so we can step through that really quick. So math.max is super useful, a built-in JavaScript method. In general, the min and max methods take in comma-separated arguments, right? So I can ask, hey, what's the max between 5, let's say 3, 7, and 2? And the answer there is 7. Notice that I should not pass in an array. You have to pass in your values just as separate arguments, right? However, if you had an array, let's say I did let nums equals that data. So I'll just copy these values, I think. If you had an array of those numbers, you can't actually pass that directly into math.max because it looks for multiple arguments. Technically right now you're giving it just one argument that is an array. And so to overcome this, what you could do is just spread out the elements of the array. Right? Whenever you use the spread operator or the 3 dots in JavaScript, you can imagine that you're just dropping these square brackets. So you just get some comma separated values, right? So that's all we're utilizing here. So I think this code is ready to test, in my opinion. Let me exit this out. And if this works, I think I have the answer down below. We should get 806. So let's give it a go. We'll do node part 1. Nice, and there I have my final answer of 806. Not too bad of a problem, and I do like how we kind of reused our binary find function, just making it more dynamic for the rows and columns. Let's head back to the drawing board and talk about what we need to do for part 2. All right, now let's talk about part 2. In part 1, we were basically able to find all of the seat IDs on the airplane, and then we had to return the maximal seat ID. This time around, they tell us that we want to find our own seat, and it's the only seat ID that's missing. And so the trick here is, how can I actually figure out my exact seat number? Well, they do tell us that among all of the seat numbers, our seat is the only missing one. So if I had every seat number, what I could do is just really sort them. Then I can look through the sorted array of numbers and figure out which number is missing. In this case, I would be at seat 42. So that would just be the answer that I return. This shouldn't be too hard to implement. I think we'll just use a built-in sort method. So here I have my part 2 file open. I just went ahead and copied all of the code from part 1. So what I'll be sure to change is I definitely don't want to just return the max ID, right? And we can still keep the work we did to get just the array of all of these seat IDs. And so let me just console.log those seat IDs, make sure they're intact. So I'll run part 2. Nice, and there I see all of my seat IDs. Notice that they don't follow any particular order or pattern, so we'll want to sort them. I'm just going to go ahead and use the built-in JavaScript sort. So I can say const, maybe my sorted IDs, and I can do IDs, or in general, array.sort. And the really important thing about the sort method in JavaScript is you have to actually pass it a function that will perform the comparison. So some very kind of standard JavaScript code here is, if you want to just sort them numerically, you'll take in both elements at a time, so just a pair of elements, and you can do like a minus b as the return value of that callback. And so let's just see what that looks like, and I'll explain how the built-in sort works. So for sorted IDs, let's see what this looks like. Cool. So you can already see that they are sorted in increasing order, right? So I recommend you look at the documentation for the array.sort method, but you always have to pass it a callback, right? So you always pass it a function. The function takes in 2 arguments that represent just like any 2 elements of the array. And then you can write some expression or some logic that returns a number, right? If it returns a negative number, then A is going to be placed before B within the array. On the flip side, if it returns a positive number, then B is going to be placed before A inside of the array. And if it's 0, then the order of them doesn't matter. It's kind of just like a tie. So that's just some classic JavaScript code, and you could probably already gather that. If you wanted the other order, you could say just B minus A. And now I have a decreasing order, right? I'm going to bring mine back to increasing order, although, the symmetric argument could be used either way. So now that I have this sorted data, what I'll do is just go ahead and iterate through and look for the gap, right? So this is really straightforward. I can just say, let I equal to 1. So I'm just going to use an index here, and I want to go up to I less than, we'll say, sorted IDs dot length minus 1. What you'll notice here is I'm kind of adjusting the bounds of my iteration. So I'm kind of going to skip the first iteration, and I'm also going to avoid the very last iteration, because they tell us that in the context of the problem, our seat isn't in the very first ID or the very last ID. So we're just going to check kind of internally. Otherwise, I may get some weird, out of bound array stuff. But overall, all I need to do is maybe grab my current element. So I'll say const cur is going to be sorted IDs at index I. Then I'll go ahead and grab my next one. So that'll be moving next, and that'll be sorted IDs of I plus 1. And so what should happen is current and next should just be like sequentially in order. In other words, if like current plus 1 equals next, then like all is well, right? Imagine that I had this sorted array in my terminal over here, right? At any point in time, if I'm at most of these positions, like 63 as an element, if I look at my next position, it's 64. right? And so to check that they are just like off by 1, I can just do my current plus 1 and check if it's equal to next, right? That will actually mean that I don't have a gap. So I haven't found where the gap is yet. On the flip side, if I make this current plus 1 is not equal to next, then I must be at the gap. And so if I found the gap right here, that means my next element isn't correct, but it should be current plus 1, right? So I'll return current plus 1, right? If this if statement is true, then I found the missing number, which is exactly current plus 1. So I'll save that, and we'll give this a go. I should get 562 as a result, so we'll just keep an eye out for that. Nice, and there we have our solution for part 2. All right, programmers, I think that wraps up today's Advent of Code. I'll catch you tomorrow for day 6.